Hello students, welcome to Misostudy video classes, and as it is clear from this caption on the first slide that in today's video we are going to discuss a question collection based upon JEE Advanced pattern, and the topic is your very interesting and well known topic, that is moving charges and magnetism. This topic is mainly important for its concepts, and you can say all the concepts associated in this topic, they are not difficult, very simple topic, fine. So, what we will do, one by one we will start the discussion of the questions, but I would like to mention one important aspect over here, that is please make yourself very comfortable in this entire chapter of moving charges and magnetism, because this chapter alone covers or provides you an opportunity to solve at least 3 to 4 questions, fine, in this particular examination, fine. And more beautiful aspect is they can combine, I mean the person who is setting your question paper may combine these aspects with mechanics also, maybe rotation, maybe you can say free body diagram, Newton's laws of motion. So, that is also important for this chapter. So, let us start this discussion. Now, here you have one question. I am starting with a very fundamental conceptual question, fine. Gradually I will explain what is happening on over here in this particular problem. An electron, obviously negatively charged, moving with the speed u, initial speed of the electron is u, along the positive x axis. This is something which is given with the help of this diagram. At y is equal to 0. Y is equal to 0 means as such no vertical deflection. It enters a region of uniform magnetic field B, which is along a negative z direction. So, if it is x, it is y. I tried to create this diagram very beautifully. So, z direction positive z outward to this green board and negative z is inward. So, that is why these cross showing you the direction of the magnetic field, fine. Now, it is entering at right angles. So, the electron exits from the region after some time with the speed v at coordinate y. Then you have to find out what will be the new velocity in terms of old velocity and what is the value of y, that too in a simple fashion, that is less than 0 or more than 0, fine. Less than 0 means it may be deflected in the negative direction, fine. So, let us start the discussion. Now, point wise if you analyze this problem, then you can simply say that the electron is entering perpendicular to the magnetic field. So, from this mv square upon r is equal to qvv formula, that is mv square upon r is equal to qvb. So, you can say this electron will start moving on a circular path. This is the ideal condition for that FQVB, fine. Over here you can say sin theta also. Now, as you know, the angle between V and B is 90 degree. So, path is going to be a circular path. One thing is quite sure. Now, as the electron is moving on a circular path, so no change in energy, in kinetic energy, means this magnetic force is not doing any work, fine. So, what I will say, I can mention it that the electron will move on a circular path. No change in magnitude, I am not saying direction, direction will change, no change in magnitude of velocity. Fine. So, v is equal to u. Basically, only direction is changing. So, now let us try to check the options given over here. So, possibility is B and possibility is D. Now, we have to exactly find out which one is correct option. So, as per this explanation, initial velocity and final velocity magnitude equal, fine, and it is also like that the electron will complete the circle. So, it will move where y is less than 0. So, this question was a very simple question, and that is why I mentioned it will start moving on a circular path. Fine. With this question, I would like to mention one more fact for your understanding, and that is you should try to use your right hand palm rule, right hand rule, left hand rule. So, when you are solving these type of problems quickly in just less than 50 seconds, you can revise all these three concepts: right hand palm rule, right hand rule, left hand rule. Fine. So, by revising these concepts, what exactly the profit you are going to get is that you can polish your skills of basics. Then comes next question, an ionized gas. Initially, I was not in a you can say mood to mention this term, but I thought it is better to mention it. Ionized gas itself means assembly of positive and negative charges, but I mentioned it. An ionized gas contains both positive and negative ions. Fine. So, I hope this line itself is self-explanatory. If it is subjected simultaneously to an electric field along positive x direction, okay. So, let me first allow to at least show you the direction. This is x, this is y, this is z. Now, electric field along positive x direction, it means this is electric field, okay, and magnetic field along positive z direction. So, magnetic field is this. Fine, means both are perpendicular to each other. Then, in this situation, if these positive and negative charges are moving, then what will happen? Fine. So, we have to find out what will happen. Okay. So, need not to read right now these options. First, what we will do, we will find to in which direction these charges are moving and how they are going to be governed, how their motion is going to be governed because of the presence of E and B. So, what I will do, I will draw a simple small symbolic diagram so that I can use this space for your further explanation. So, this is x, and if it is x, then it is E, fine, and this is your z, so it is B. Now, make this diagram as a reference, just keep it in your mind. And what I will do, I will explain you the situation, and then after explanation we will try to find out which option is correct. Okay. So, if I am writing E is equal to EI, yes, everyone will accept it, no problem. And if I am writing B is equal to BK, you will say no problem. So, here it is mathematical representation and here it is diagrammatically graphical representation. Now, what we can say about velocity, because in just previous problem I explained the relation. So, I thought here I have this much liberty to write down certain steps directly, fine. Now, V is equal to A Q E, fine, that is electric field I cap. Basically, it is A Q E. So, rather than writing electric vector E, I am writing this magnitude, okay, with the direction. Now, from here all other terms are constant, like A, like Q, like B, like E, everything is constant. But charge Q of these ions, so I think I should write down complete line. All other terms are constant, means they are not changing. All other terms are constant, but charge Q may be positive. Let us write it down in a simple fashion. Charge Q may be positive or negative. These are two possibilities which are given in the problem. Fine. So, now we have to decide accordingly. So, after this much, I would like to write down over here only, because if I will move away, your question is going to be away from your sight. So, I think after understanding this, I am going to write down next step, which very easily you can understand. I want to maintain the nearby approach with the question, because I have to explain all these 4 options. So, from here you can say that F magnetic force, and the formula for magnetic force is QVB. That simple result which I am going to write down, QV cross B. Fine. So, now put the value of B, which I mentioned A, Q, B, something like that. So, if you use that value over here, you can say it is Q square A E B. Fine. This is just the magnitude in x direction or in z direction, into I cross K. I hope you all are comfortable with this I cross K. Okay. So, I cross K means what in cross product? Minus J. Fine. So, directly if I am writing it as Q square A E B, fine, and minus J cap, minus J cap. So, now the expression is with you, and now you can read the options. Positive ions deflect towards positive y direction and negative ion towards negative y direction, but I am getting only one direction. So, option number A is incorrect. B, all ions deflected towards positive, no, minus direction. All ions deflected towards negative, yes. So, C is the correct option. Fine. Now, these questions are simple, but up to some extent some you can say long explanations sometimes required. So, the more better practice you have of these type of problems, the more comfortable you will find yourself in examination hall. Fine. So, try to maintain this practice session very regularly. Then comes question number 3. Now, what exactly the process, why I am mentioning a different heading over here? I know, I can understand the way we are presenting these questions to all of you. Up to now, you must have realized that we are trying to pick up all type of questions which are supposed to be asked in JEE Advanced Pattern exam, and in almost every video I am explaining it to you. That is, one option correct, more than one option correct, matrix match, and you can say integer type, analytical type. So, various type of questions. Fine. And you even do not know in next JEE Advanced Pattern what type of question they may ask. Fine. When they introduced this idea of matrix match, integer type, no one was aware, and they introduced. So, what is exactly going on in the minds of professors of IITs? Nobody knows. Fine. So, that is why I picked this question where more than one option may be correct. This is true for what? This is true, this type of questions are true for a situation where you need really to solve complete question. Because in previous question, moment you got the option correct, there is no point of moving ahead, but here you have to check all 4 options, fine. That is something which is known as approach in totality. So, let us start. And electron and proton, equal charges, opposite in sign, mass difference is large, fine. Whenever you are reading the problem, start arguing in your mind like this, fine. An electron and a proton are moving on straight parallel paths with same velocity. Straight parallel paths like this line, fine, and next is yellow line. Okay. Let us say on this white purple line electron is moving, and on this yellow line proton is moving. In which direction? No aspect of that right now to think. Fine. They enter a semi-infinite region of uniform magnetic field perpendicular to the velocity. Sentence is self-explanatory. Which of the following statements is or true? Fine. Now, there is no point of reading these statements at this point, because right now we know only the situations. We have to analyze the situation. After that, we will reach to a conclusion. Fine. So, let us take a look of this situation. What exactly the problem is? If I am writing R is equal to mv upon qv, you will say no problem, a very well known simple relation. And every time if I am emphasizing on even a very minute detail, it is not like that I am wasting your time, but I am emphasizing on this aspect that more the close you will be with the basic concept, more marks you are bound to get. Moment you start coming out from the basics, JEE advanced pattern exam is going to be horrible for you. But if you are close with the concepts, advanced pattern exam is like cakewalk. Fine, you accept it or not, it is the reality. Because I was the part of this, then I completed my degrees, so it is like that way only. R is equal to mv upon qv. So, what I can say from here, at least R is directly proportional to m. Now, you can say why? Okay, very good, if you are not accepting. Same velocity mentioned in the problem. Magnetic field same. And what I mentioned in the starting of this question, charge on proton and electron same, only sign is different, magnitude is same. So, V, Q, B, everything is same. So, if I am saying R is directly proportional to m, m means what? Mass of electron, mass of proton. And for your information, mass of proton is equal to 1840 times mass of electron. Fine. So, that is why more the mass, more the radius type of situation you will get. Fine. So, let me allow to write down the relation with a different approach, that is R is directly proportional to m, equation number 1, and mass of proton is very, very large than mass of electron. So, these are two facts with which we created this equation. Basically, I gave the name 1 and 2 to this fact. Fine. Now, if it is like the situation, then what I can say? Radius of electron path is less than radius of proton path. Directly proportional. Fine. So, if it is true as 2 from, sorry, I think I should write it this way, as given in 2. Fine. No problem with this particular explanation. So, T is equal to 2 pi m upon qv, a well known relation for time period. Okay. Now, if this relation we want to find, then again take a look everyone, 2 pi q b, everything is same, 2 pi q b, everything is same. So, if I am saying now from here that T is, let us use, T is directly proportional to m, you will say yes, no problem. So, mass of electron Te is less, mass of proton Tp is more, acceptable. Okay. So, Re less than Rp, let me allow to write it down over here, Re less than Rp, first fact. Okay. And then I can use this space, Te is less than Tp. Reason I explained to you. So, from here what you can say that time period for electron is less than time period for proton. So, now let us start analyzing the fact. They will never come out of the magnetic field region, no, they will come out. So, option A is not correct one. They will come out travelling along parallel paths, yes. Why? Let me show you quickly. Fine. Similarly, it will enter over here, come out over here. So, parallel entry, parallel outgoing. This is the path. So, they will come out travelling parallel path. So, this B option is correct. They will come out at the same time. No, just we calculated T of electron is less than T of proton. They will come out at different times. Yes. So, question is simple, but what they did? They combined two basic aspects together, and this way they are forcing you find the all conditions, analyze all the given conditions. Fine. Here comes question number 4, and this question I placed in a specific category of analytical. Analytical means no option is given, you have to solve the problem. Now, actually this problem, you can say these type of questions they are not asking right now, they converted these questions in the form of integer. But integer type question you can solve only if you have the capacity to read, understand and solve the question with analytical approach. So, I thought let us share with my students this approach, after that brilliant students can solve the question properly. So, here is the problem. Proton and an alpha particle after being accelerated through the same potential. Now, moment I am starting this explanation, proton and alpha particle, then at least 1-2 basic facts should come in your mind. That is fact number 1, proton, okay, mass is alpha particle is 4 times more, fine. Charge of proton if Q, then charge of alpha particle is double of that, and it is also positive. So, this way if you start thinking in your mind while you are preparing for this exam, in examination hall you will find yourself in a very comfortable position. Fine. Accelerated through the same potential means kinetic energy. They enter uniform magnetic field, then direction of which is perpendicular to their velocity. So, that situation is simple, perpendicular. So, they have the tendency to move on a circular path. Find the ratio of radius of circular paths of two particles. Fine. Just because of the mass difference, just because of the charge difference, radius is going to be different. So, let us allow to solve this particular problem using these basic concepts. Fine. R is equal to, rather than writing R is equal to mv upon qv, I am writing the formula directly in the terms of equal R. fine. So, R is equal to 2 Q Vm upon QB, fine. Vm is potential, maximum kinetic energy or potential with which they are accelerating. Now, from here what I can say? I can say R is directly proportional to what? Directly proportional to this m upon q. I think I should change this formula in this fashion. Basically, it is either Vm or you can write it Km. Both way you can write it, fine, because kinetic energy is same, 2 is constant, meaningless. Mass B is also same, only difference is mass and this charge, fine. So, R is directly proportional to m upon q. Another thing is, if directly I am writing Rp upon R alpha. What is the meaning of Rp and R alpha? Radius of a proton's path, proton's path and a radius of this alpha particle. So, R of proton upon R of alpha is equal to mass of proton upon mass of alpha particle into under root q alpha upon qp, fine. Now, easily you can find out that just by putting the value, mp means m alpha means 4, q alpha means 2 and qp means 1. So, by solving it easily you can say that this ratio is 1 by root 2, 1 by 4, 2 by 1, that will give you 1 by root 2. Fine. So, this question is not a difficult category question, basic simple question, where only you just have to apply a well known small result twice, fine. Initially, I am picking these fundamental question just to create some sort of curiosity in your mind, and also to prove that JEE pattern exam, advanced pattern exam specifically, is not a difficult exam. Now, big question, difficult question, not like that. Read the question. Two very long straight parallel wires carry steady current I and minus I. What is the meaning of I and minus I? This one is one wire, and let us say for example, this one is another wire. I minus I means if one current is in this direction, then another current is downward direction. So, directions of the current in both wires is different. Now, after this understanding, the distance between the wires is d, this distance is d given. At a certain instant of time, a point charge q is at a point equidistance from the two wires in the plane of the wires. So, let us say charge is placed equidistance over here, d by 2, d by 2. Its instantaneous velocity v is perpendicular to this plane. Here v, here v, here v, here v, everywhere v. It is independent. The magnitude of force due to magnetic field acting on the charge at this instant is how much? Means magnitude of the force. So, which force? Magnetic force only acting. So, we have to talk in terms of that magnetic force. Fine. So, I hope the diagram is clear to all of you. So, let us take the look of the solution of this problem. Just to show you the situation, here I am giving you a symbolic diagram. Okay, x, y, z. Now, because of the direction of the current, magnetic field due to both wires is downward. Fine. If the wires are like this, magnetic field is both wires downward. B net is downward for both wires. I think I should redraw the diagram, because if the diagram is not present, it is going to be slightly difficult for all of you to visualize it. Now, I am taking the look of the diagram from the top. The wires are like this, fine. One wire is this, another wire is this, and I am taking the look from top like this. So, that is why I am drawing this diagram. Okay. And this is not for the magnetic field, this is for what? This is for the direction of this current, which one is in which direction. So, it is your B, it is your B, and these wires are separated by a distance D. Fine, these wires are separated by a distance D. Now, in this particular problem, from the diagram it is clear that velocity and magnetic field both are parallel to each other, 180-degree angle, fine. I think I should write it down over here. V and B at 180-degree. So, F is equal to Q V B sine of theta. I do not think anything left for me to say, that is correct answer is 0, because sine 180 is what? So, this way students, we completed the discussion of these 5 questions. I do not want to make the video very long, that is also quite boring, fine. So, without any excuse, we are stopping over here. Very soon in future we will come back with more set of questions, that is second episode of this serial. So, till then keep revising, take care of yourself, thanks.